Good day, grade 12 learners. Welcome to today's mathematics lesson. This lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center. I forgot to mention my name. I'm Insindane. Our lesson for today is revision for paper 2 and will focus on analytical geometry and trigonometry. Please note, you have written paper 1. Please do not entertain anything about paper 1 from now until you finish your paper 2 on Monday. Otherwise, it will disturb you. Just focus on paper 2 revision and prepare thoroughly for paper 2. Now, our lesson for today, as I've indicated, we are looking at geometry, analytical geometry and trigonometry. Yes, now our targets. We know that for paper 2 we have 4 topics. Statistics has between 17 and 23 marks. Analytical geometry has between 37 and 43 marks. Trigonometry has between 47 and 53 marks, and Euclidean geometry has between 37 and 43. Our focus is analytical geometry, and our minimum target there should be 18 out of 40. But for a bachelor pass, we should aim for 25 out of 40. Trigonometry, these are minimum marks. You should get all the marks. Trigonometry, our minimum target should be 23. For a bachelor pass, it should be 35 and above. Now, remember, whatever is your target, you get it per each question. Try to make sure that on each question, you get your minimum target percentage so that you are able to get the level that you want to get. Moving forward, we have our information sheet. Please, let's make sure we use our formula page so that we do not write wrong formulas and we lose marks unnecessarily. For analytical geometry, we are going to use these formulae that are there on our formula page. Distance formula, midpoint formula, our equation of a straight line. We have 2 versions. Please choose one that you have mastered. Our gradient formula, our angle of inclination is equal to the gradient, and then we have the equation of our circle. If the center is at the origin, we know that our a and b there will be 0, which will give us x squared plus y squared is equal to r squared. For trigonometry, we have our compound angle identities. We also have our double angle identities. We have our sine rule. We have our cosine rule, as well as our area rule. Now, by the end of the lesson, you should be able to revise concepts of analytical geometry, determine the equation of a circle and a tangent to a circle, determine the relationship between a circle, a point, and a line. And we should be able to determine the relationship between circles, whether the circles intersect internally, externally, or do not intersect. We should revise and use concepts of trigonometry to solve trigonometry problems. We refer to our CAPS document on page 47, as well as our examination guidelines for grade 12, 2021 on page 8. Now, I have attached a checklist that you will use, and I hope you also have received it so that you are able to see which parts you still need to look at between now and Monday, so that when the exam comes, you will be comfortable with all the sections. Our distance formula between 2 points, if I have 2 points, point A and B, and I have a line segment, the coordinates of A will be x at A, x at B, and then x at A and y at A, x at B, as well as y at b. We use our distance formula. We should be able to use that one. The coordinates of the midpoint, we know that the distance, if I call this m, the distance mb should be equal to the distance am. The gradient between 2 points, we know our gradient formula. Our gradient of AB becomes y at b minus y at a over x at b minus x at a. Please use the coordinates, the values of those points. Let's avoid x1 and x2 because we normally interchange them. Let's use so that you are able to see that you are substituting the y at b, the y at a, the x at b, and the x at a. Because if you use x1, x2, you might even swap them around and you end up getting a wrong gradient. The relationship between gradients of parallel lines, using the relationship to perform calculations. We know that if two lines are parallel, if AB is parallel to CD, we know that the gradient of AB will be equal to the gradient of CD. And then if two lines are perpendicular to each other, we know that the product of the gradients, the gradient of AB times the gradient of CD, should be equal to -1. When we have lines that are perpendicular to each other and you are able to deduce, if you are given the gradient of one line, you are able to deduce the gradient of the other, even if you are not given the 2 points on the other line. Now, collinear points, we know that these are points that lie on the same line. If I have 3 points A, B, and C, I know that the gradient of AB should be equal to the gradient of BC, which should be equal to the gradient of AC. So you just take, if they are collinear points, they lie on the same straight line, they will have equal gradients. The angle of inclination, we know that that one is determined by the angle a line makes with the positive x-axis. If we have a line like that, this becomes our angle of inclination. We also have one where the angle of inclination is obtuse. And normally, if the angle is obtuse, our gradient is going to be negative. If our angle is acute, our gradient will be positive. Now, the equation of a line segment, we showed you the equation of a straight line. Y is equal to mx plus c, or you use the other version. Now, the intersection of a straight line, finding the coordinates of intersection or a vertex. Sometimes you'll be asked to find the angle between two lines that are intersecting, as well as finding the coordinates where you might need to solve the equations of the two straight lines simultaneously to find the point of intersection, which will give us the coordinates at the point of intersection of those lines. Our angle of inclination to calculate angles of geometric shapes, that is our quadrilaterals as well as our triangles. Now, we know that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. That's what we are going to use, and you are going to find scenarios like this, where this is the angle of inclination of that line. You have the angle of inclination of that line. You are expected to find the size of this angle. You use the gradient of this line to find the angle there, and you are able to find, using the gradient of that line, to find of the angle of inclination. Let me call this one alpha, I call that one beta, and I will call this angle here theta. We are able to say beta plus theta will be equal to alpha, using the exterior angle of a triangle is equal to the sum of the two opposite interior angles. And then You are able to get beta from the angle of inclination. You are able to get alpha from the angle of inclination. You can deduce theta there. Now, the properties of our triangles, please let's go back and we make sure we know them. An isosceles triangle, we know that we have two adjacent sides that are equal in length, and we also have angles opposite equal sides. The angles will be equal there. You will have two equal angles. We have two sides that are equal. You are able to calculate the third angle or the third side using your distance formula there, or your cosine rule or sine rule, depending on the type of triangle that you are working with. Now, the properties of quadrilaterals. Please, we must know these. We have been doing quadrilaterals since primary schools. We know our properties of a rectangle, a square, parallelogram, rhombus, kite, trapezium, and we should be able to use their properties to deduce the type of a quad that we are working with. And we use analytical methods. We know that in a square and rectangle, we must have sides that are perpendicular to each other, and you have a pair of opposite sides that are equal in a rectangle and also in a parallelogram. But how do you differentiate between a parallelogram and a rectangle? How do you differentiate between a square and a rhombus? We must be able to use analytical methods to do that, and we have a summary of these from our literature. Let's look at them and we use those. The properties of the diagonals, also we must know them. Moving forward, now we use the area of quadrilaterals, triangles. We use area rule, area formulae with a perpendicular line. We must know how to find the area of a rectangle, the area of a parallelogram, the area of a trapezium, because it can be asked in the exam. How do we find the area of a triangle? If the triangle is not right-angled, we use area rule there. The equation of a circle, center at the origin, I've given a hint, x squared plus y squared is equal to r squared. We should be able to do that. Center anyway in the Cartesian plane, we know we are using x minus a squared plus y minus b squared is equal to r squared. We also have the equation of a circle being written as x squared plus y squared plus bx plus cy plus d equals to 0. We must be able to move in between the two forms of the circle equations. If you are given this form, you must be able to deduce the standard one. If you are given the standard, you must be able to move it and write it in the other form. Also, the equation of our straight line, we know we are used to writing it as y is equal to mx plus c, but sometimes you may be required to give the equation in the form ax plus by plus c equals to 0. We should be able to move in between the two forms of the equation of a straight line, circle, as well as the equation of our tangent to a circle. And we use the property, a radius is always perpendicular to the tangent, and from there we also know that we should be able to determine the length of the tangent to a circle. In most cases, we use theorem of Pythagoras, using the property that a tangent is perpendicular to the radius, and you are able to form a right-angled triangle. When given lengths there, you are able to use either your distance formula. If you are given coordinates, you get the distances or the lengths of those parts of the triangle that you form, or apply theorem of Pythagoras. The relationship between a circle and a point, whether the point is inside the circle, outside the circle, or is at the circumference of a circle, using the distance formula to calculate the distance between the center and that particular point. You compare it with the radius to deduce whether it's outside, inside, or on the circumference. Now, a line, we should be able to deduce whether a line is a tangent to a circle or it is a secant. When it's a tangent, it touches the circle at only one point. When it is a secant, there are 2 points of intersection. When it does not intersect the circle, it will be outside. And we should be able to use our nature of roots to help us determine whether the equation of the line intersects the circle there at 2 points, 1 point, or it does not, as well as using our knowledge of simultaneous equations. Now, we move on now. The relationship between two circles. We know that one circle can be inside the other circle, or the circles can intersect externally, or the two circles can intersect at two different points, or the two circles can be apart. There will be no point of intersection. In most cases, we are using the radius of the bigger circle plus the radius of the smaller circle, and you also compare the distance between the two centers there. Now, I don't want us to keep on talking. Let us write activities to check whether we still remember these concepts, and I will give you 7 minutes to write activity 1. Welcome back. Now, please read the statement before you go for the questions. In the diagram, A with coordinates 3 and 4, B and C are the vertices of a triangle. A, B, C. They form that triangle. D and F are the x and y intercepts of AC respectively. F is the midpoint of AC. So we know that the distance FC is equal to the distance AF. It's the midpoint. Now, we are told that the angle of inclination of AC is alpha. The equation of AB is y is equal to kx plus 3. They have given us there. The equation of AC is y is equal to 2x minus 2. We have to show that k is 1 over 3. We have the equation of that straight line. So the easiest thing to do there, we have to show that k is 1 over 3. It has to come at the end. We use the coordinates of point A, and our x is 3, our y is 4, and we'll only have one unknown as our k there. And we substitute and show that our k is that one. So if you check, this is 1 mark, you'll get a mark for the method. Others, you could choose to use the gradient. Now, how do you use the gradient? You have to show that the gradient of that line AB is going to be 1 over 3. And you are able to deduce that our A is that one, and you have to show that that one is there. So the easiest one is this one for me. You get your 1 mark. 1.2, you have to calculate the coordinates of B, the x-intercept of line AS. So even if you have failed to answer 1.1, you must be able to get the marks for 1.2 because they've given you that k is 1 over 3, which means your starting point, where there's k, you can put 1 over 3. It means the equation of that straight line will be y is equal to 1 over 3 x plus 3. That's what you are using to move forward now. So the coordinates of B, this is the x-intercept. We know that for our x-intercept, our y is 0. We substitute on our equation. 0 is equal to 1 over 3x plus 3. We then transpose 3, we get negative 3 is equal to 1 over 3x, and then this will give our x as negative 9. The question was specific, the coordinates of B. So you must make sure that your x-intercept, you write it in coordinate form, because the key thing there, coordinates of B. So 9 and 0, and for the method, you get your 2 marks there. We are supposed to calculate the coordinates of C. Our starting point, again, as you get this information, please add it to your diagram so that you are able to see where you are going. Now, first of all, we need to get the coordinates of F. F is the y-intercept. How do we get the y-intercept? We let x to be 0. We use this equation there. And we'll get the coordinates of F as 0 and negative 2. The coordinates of D, we are able to see that D is the x-intercept, and this will give us 1 and 0 like that. Please add information to your diagram. It will make your life easier. So, to get the coordinates of C, I need to find the coordinates of F first. I found the coordinates of F. And then I use my midpoint, so coordinates of F, I get a mark. The method, I have an x at A, I don't have an x at C. I have a y at A, I don't have a y at C. These should be equal to the coordinates of the midpoint. That is the method I am using. Then I get my x value at C and my y value at C. as -8. I get my 4, 2, 1. I hope we also got 7 out of 7. Next activity, please be ready. You will have to write the activity because we need to have confidence in what we write. We can't just discuss things. You need to write them so that you are able to see whether you are able to do it or not. Next question, it's our activity number 2, and I'm going to give you 5 minutes. The story is still the same, only the question has changed. 5 minutes. Welcome back. Now, remember, as I indicated to you, as we get information, please let us add it to our diagram so that it makes our life easy. We got the coordinates of B as -9 and 0. We got the coordinates of C as -3 and -8. Now, we want to find the coordinates of S are given as -15 and -2. So we want to find the line equation of a line which is parallel to BC. Visualize it passing through that point. So for us to see that, we know that BC is parallel to that particular line. We do not have its gradient, but we only have a point. So to deduce its gradient, we are using the property that parallel lines have equal gradients. So we get the gradient of BC. We get it as -4/3. We substitute the coordinates of B and C. We get the gradient, and we are using the fact that the gradient of BC is equal to the gradient of line, because these are parallel, so they will have equal gradients. We use the equation of a straight line. We deduce the gradient will also be -4/3. We substitute the coordinates of point S, and we get our equation as y is equal to -4/3x minus 22. I don't know whether it's pressure or what. Some of us do not finish. We end up, the question asks for an equation, we end up just writing C is -22. We will not get marks if we do that. We must write the equation in the form that the question has asked us to do. So we must write the equation as our final answer. We should not just find the value of M and the value of C and we leave it there. With that being said, please let's look at the other form. Sometimes instead of the question asking us to leave the equation in that form, they may ask us to leave the equation in the form ax plus by plus c equals to 0. Please, we should be comfortable in moving in between these two forms of our equations. Y is mx plus c, as well as that one. When you are given that one, you must change it so that it looks like that, so that you are able to deduce your gradient. If you are given this one, you must be able to write it also in this form if it involves fractions, as I have demonstrated there. Our LCD, it will be 1 here, 1 there. Our LCD there becomes 3. So you multiply each term by 3 and you make sure that you take everything to the left-hand side of the equal sign, so that on the right-hand side we have our 0. Moving forward, activity 3, it's 5 marks. Let us answer it in 5 minutes. Welcome back. Now, I hope you were able to answer that question. For us to calculate the size of angle BAC, if you check, I will focus on triangle ABD and I will highlight that triangle so that you are able to see. Now, from there, you are able to see that we are able to deduce the gradient of AC. We deduce it from the equation, it's 2. The gradient of AB, we know that it is equal to 1 over 3. And we did that one. So we use the gradient of AC to help us get that angle. And then from there, the gradient of AB or AS will help us get the angle 18,43 degrees. And then from there, we are using the fact that our exterior angle of a triangle, which is alpha, minus ABD will give us the angle. So we have this angle here, we want that angle there, and this becomes our exterior angle. It is equal to the sum of these two. And we are able to deduce that this will be 63,43 degrees minus 18,43 degrees, and we get BAC as 45 degrees. Others decided to use area rule. You can use area rule, but area rule will be a bit of a push because we do not have the area there, but you can use your cosine rule, your sine rule, because you are able to deduce the measurements of all the other sides there using your distance formulas. From there, you apply your trigonometry there. Sine rule, cosine rule will help us get that angle of 45 degrees. Moving forward, this is not the only option. I chose the one that is easier. Hence, if you used a different method, it's still fine as long as we get our angle as 45 degrees. This is not the only method that we can use to get that angle BAC. 1.6, we are given further that the length of AC is 6√5 units. We have to calculate the area of triangle ABD over the area of triangle ASC. 5 minutes. Let's do the activity. Welcome back. Now, let's identify the triangles. It is further given that the length of AC is 6 root 5 units. Now, let's calculate the value of the area of triangle ABD over the area of the triangle ASC. Our triangle ABD, it's this one. Our triangle ASC, I'll use wavy lines for it so that you are able to see it. Now, we have two triangles, and if you check, the triangles share a vertex A, so there is no perpendicular line which is common, so we'll use the area rule. So the area of triangle ABD will be given by, we use our distance formula to deduce the other length, our AS, we are able to get it as 6 root 10. Our AC, we are able to deduce that it's 4 root 5. Our SC is given as 6 root 5. We are able to see that one there. And our AB, as you can see, it's going to be 4 root 10. And the length of BS is going to be that. And the length of our AD is 4 root 10. So now our AD is 2 root 5. Our AB, we are able to see that it's 4 root 10. Now, let's go to how we are going to look at that one. The area of triangle ABD, it will be half AB times AD sine A. The area of triangle ASC, it will be half AS times AC sine A. And if you check the half and the half goes, the sine A will go. So our area will be given by that, and we should be able to get our answer as 2 over 9. So substitution, and we get our simplification to give us our answer as 2 over 9 there. So please, anything with a diagram, the answer should be in front of you. Use your diagram effectively and use the analytical methods. You will be able to see that it's doable. Now, we are now moving to a circle, and I will give you 6 minutes to answer 4.1 up to 4.3. Welcome back. Let's read the statement. In the diagram, the circle centered at C, so C is our center, is drawn. A with coordinates 5 and 1, B with coordinates -3 and -3 are points on the circle, or sometimes they say points on the circumference. E is the midpoint of AB. What comes into your mind? We know that AE should be equal to BE. They are equal in length, and we are supposed to calculate the coordinates of E, the midpoint of AB. There we are going to use our midpoint. It will be our x at A plus our x at B over 2, our y at A plus our y at B over 2. We will get the coordinates of the midpoint, and that gave us our answer as, we get our answer as E will have coordinates 1 and -1. 4.2, we are supposed to calculate the length of AB, and we leave our answer in said form. We are using our distance formula. We are using x at A minus x at B squared plus y at A plus y minus y at B, and we are squaring that to help us get the distance, and we should get our distance as square root of 80, or we leave it as 4√5 units. The question is specific. Leave your answer in said form. If you leave it as a decimal, you will not get a mark because you did not answer the question. Determine the equation of the perpendicular bisector of AB in the form y is equal to mx plus c. Perpendicular bisector to AB. So it means we want the equation of this line here, CE, and it goes all the way. We know that the angle here must be 90 degrees for it to be a perpendicular bisect. Line from center, perpendicular to a chord, bisects. Now, looking at that, what comes into our mind? We are able to get the gradient of AB, and we should use the gradient of AB to help us deduce the gradient of CE, which is our perpendicular bisector. So with that being said, we get the gradient of AB, we get it as half. We then deduce the gradient of CE as -2 because AB is perpendicular to CE. From there, we use coordinates of point E. We say the coordinates of point E are 1 and -1. We substitute into our equation of the straight line, and we get the equation as y is equal to -2x plus 1. We get our 4 marks there. We move on now to the next activity. It is still based on the same scenario. As I indicated, please add information to your diagram. It will make your life easier. Now, our activity 6. We are supposed to show that P is -3. We are supposed to show by calculation that the equation of the circle is x squared plus y squared minus 4x plus 6y minus 12 equals to 0. I'll give you 5 minutes to answer 4.4 and 4.5. Welcome back. Now, if you look at this question, it says show that P is negative 3. We should get the value of P. Now, we deduced the equation of CE, which is a perpendicular bisector, and we said it passes through that point. And we got the equation of P as y is equal to negative 2x plus 1. So we are going to use that equation. We substitute our x as 2 and we substitute our y as P, and we should get the value of P as negative 3. That's how we got it. We substitute that and we should get our P as negative 3 like that. Now, the next question says, show by calculation that the equation of the circle is x squared plus y squared minus 4x plus 6y minus 12. Remember, we said there are two forms of our circle equation. We have the standard form, which we shall use to deduce this form. So, what you will do, you know that you are able to deduce, if you check BC becomes the radius. Here we have our negative 3. Here we also have negative 3. It means this is a horizontal distance. We are able to deduce that our radius is going to be 2 minus negative 3, giving us 5 units. And the equation of our circle, we know that it's given by x minus our x at the center is 2 plus y minus negative 3 all squared is equal to our radius is 5 squared. We will expand this and we get our equation as x squared plus 4 minus 4x plus 4 plus y squared plus 6y plus 9 equals to 25, and then you collect like terms on the left hand side of the equal sign and we get our equation as such. So you get that for 5 units. Substituting into the standard, we expand and we collect like terms and we should get our equation in that form. Please do not start here and try to work backwards. This must come at the end. So you start with the standard form, you end up with the expanded circle equation there. We have our 5 marks. 4.6, this one I will not give you a chance to answer it, but I will discuss it with you in the interest of time so that we are able to cover also trigonometry. We are given the diagram. We are supposed to calculate the values of t, for which the straight line y is equal to tx plus 8 will not intersect the circle. Now we have the equation of our circle, which is given as such, and we have the equation of the line. So we are going to use the fact that we want to solve for x and y simultaneously, so this becomes our equation 1 and this becomes our equation 2. We will substitute and we should get our equation in the form x squared t squared plus 1 as the coefficient of x squared, and we have 22t minus 4 and the coefficient is x, and we have 100 as our c. As I indicated, for this one we use our nature of roots to help us check. So if the line does not intersect, it means our delta has to be less than 0 so that the equation will not have real solutions. So we evaluate our delta and we solve the inequality delta is less than 0. And Our A is t squared plus 1, our B is 22t minus 4, and our C is 100. We substitute into our delta, and we should get 21t squared minus 44t minus 96 is less than 0. We factorize, and we get our critical values as negative 4 over 3 and 24 over 7. So it means our t, we are solving an inequality here, and our t should be between negative 4 over 3 and less than t less than 24 over 7. We get our 6 marks there. Now, forming our substituting, getting our standard equation, knowing the use of delta, that our delta should be less than 0, and getting our critical values, and we should get our 6 marks. This is a question that requires us to think outside the box, and we should expect such questions where we use our nature of roots. If they said it's a tangent, it means we will have repeated roots and we'll only have one point of intersection. If it was a secant, then it means we should be able to get 2 points of intersection there as our values of t, where this will intersect that at 2 different points, as you can see. Now, it's an interesting question, but let's look at also how our circles intersect, how a point, we can deduce whether the point is inside the circle or outside the circle. With that being said, we shall move over to trigonometry aspects. We started trigonometry by looking at right-angled triangles, knowing that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tangent is opposite over adjacent. We then moved over to our cast diagram, where we are deducing trig ratios used in the form x, y, and r. You should also be able to use our compound angle identities to deduce the other compound angle of identities when you are given one. We should be able to solve problems where compound angle formulae are used. Remember, you can use compound angle identities to expand or to simplify an expression. So we should be able to expand and also reverse them so that we have a simpler expression at the end. We use our compound angle identities to derive double angle formulae and solve simple problems involving double angles. Now we apply our formulae there. We should be able to solve problems involving drawing of the terminal arms by first identifying the quadrants where the terminal arms will lie. Remember our cast diagram. We know that all are positive, sine is positive, tan is positive, and cos is positive. And we also know that this is our 0 degrees, 90 degrees, we have our 180 degrees, and we have our 270 degrees. Then we have 360 degrees. We move in an anti-clockwise direction. When we are dealing with positive angles, we'll quickly look at this in no time. We solve problems where trigonometric ratios are expressed as letters. We are aware of this one. We solve problems where reduction formulae, cofunctions, negative angles, and multiple rotations should be used. We will discuss this as we move forward. We solve problems involving numerical reductions, where special angles can also be integrated. We solve trigonometric identities. We should also solve problems that involve general solutions. We determine values where identities are undefined. We sketch trigonometric functions. We interpret sketched trigonometric functions. integrating the general solution with trigonometric functions to determine x values of the points of intersection, and also solving problems like f of x greater than g of x, f of x minus g of x equal to a particular value, as an example. So we should be able to solve such problems. We should also be able to prove the sine, the cosine rule, as well as the area rule. We use our sine, cosine, and area rule to solve two-dimensional and three-dimensional problems. Now, remember, this is the theory where we started with our right-angled triangle, theorem of Pythagoras, to help us get our trigonometric ratios. We then moved to our Cartesian plane, where we started finding the trig ratios in terms of x, y, and r. We also look at our quadrants, as I've indicated, 0 degrees, 90 degrees, 180, 270 degrees, and we have our 360 degrees. We apply our reduction formula. We know that in the first quadrant, we are dealing with theta and 90 minus theta. In the second quadrant, it's 90 plus theta, or 180 minus theta. Third quadrant, 180 plus theta. And in the fourth quadrant, we use 360 minus. I avoid 270. It's a cofunction, and we all know, right? Our Pythagoras theorem there. Moving forward, we know that 90 minus theta and 90 plus theta, our ratios change and we call them cofunctions. Now, our reduction rules in our cast diagram. Let's refresh our memory. We know that in the first quadrant, we are dealing with that, and we are able to see which ones are positive, which ones are negative. The reduction of sine 90 minus theta is cos theta. The reduction of cos 90 minus theta is sine theta. The reduction of sine 90 plus theta is cos theta. The reduction of cos 90 plus theta is negative sine. Remember, in the second quadrant, cos is negative. That's why its reduction in terms of its cofunction is also negative. We have 180 minus, we know the reductions there. 180 plus, we get those reductions, and then we have 360 minus, and then we deal with our negative angles. The reduction of sine negative theta, it's negative sine theta. The reduction of cos negative theta is cos theta. Remember, we said for our negative angles, we are moving in a clockwise direction. So this is where we have our negative theta. That's why we are having them as negative. But because cos is positive, also cos negative theta will also be positive there. Tan negative theta is negative tan theta. And whenever we have an angle which is greater than 360 degrees, we keep subtracting 360 from the angle until we get an angle in the interval 0 to 360 degrees. Sometimes also when you are given a reduction like sine theta minus 1/8 as an example. Instead of you not factorizing that, you can just add, say, negative 180 plus 360. This will give you sine 180 plus, and you are able to apply from the knowledge of our normal reductions that we are used to. Moving forward, we have our identities. These ones, we must know them. We have been doing them ever since. These are not provided on our formula page, but we must know them. Cos squared plus sine squared theta is equal to 1. Tan theta as an identity is sine theta over cos theta. And we are going to do this activity. I will give you 6 minutes to answer the first activity. Welcome back. We are given that sine 40 degrees is P. We are supposed to determine the following in terms of P without using a calculator. Check, this is in bold letters. You use a calculator there, you are gone. So now, to help us do this one, we can either use our cast diagram, but this one you will find in most cases we are using our now. It means the coordinates here will have P, so we'll have X, sine X and P, and our R will be equal to 1, because we know that sine it's Y over R, which means this is P over 1, which is our P is 1, our Y is R, which will give us our hypotenuse. We have our right angled triangle there. This is our 40 degrees, and this angle here will be 50 degrees, and this one will be 90. To just visualize what's happening. Now, sine 220, we know that this one is in the third quadrant. It's 180 plus 220 plus 40 to give us 220. And it is the reduction of sine 180 degrees plus 40 degrees. And this will give us negative sine 40 degrees, which will give us our answer there as negative P. So you just do the reduction, you get your answer. Cos squared 50 degrees. Now we know that cos 50 degrees is cos 90 minus 40, and that one will give us sine squared 40 degrees, and sine 40 we found out it's P, and that should give us our answer as P squared. 1.1.3, we want cos negative 80. We use our reduction rules. Cos negative becomes cos negative 80 degrees. Its reduction is cos 80 degrees. But if I look at this cos 80, it has a relationship with that P. It is the same as writing this one as cos 2 times 40 degrees, which is our double angle identity. And for cos, we know cos double angle, we know that we have cos 2 theta, we can write it as cos squared theta plus, sorry, it's minus sine squared theta, or we can write it as 2 cos squared theta minus 1, or we can write it as 1 minus 2 sine squared theta. So because according to our function we are given our sine 40 as P, so we should use sine to make our life easy. We will get 1 minus 2 sine squared 40 degrees, and where there's 40 degrees we put our P, and we should get our answer there as. So we'll get a mark for using the correct double angle identity using 40 degrees and substituting for P to give us 1 minus 2P squared. We should be able to get these marks. They are straightforward. Second activity, we are given that cos sine beta is 1 over 3. Where beta is between 90 degrees and 270 degrees. Without using a calculator, we should be able to deduce the following. Now, we should be able to answer that question in 6 minutes. Welcome back. So to answer this question, without using a calculator, we are going to use our diagram. Fortunately, this one, it's already, we know that sine, we said it's y over r. Now, our y value is going to be 1, our r is 1. We draw our diagram in the second quadrant, and our y is 1, our r is 3. We use Pythagoras theorem to help us get our value of x, and we'll get x squared as 8, and our x will be plus or minus the square root of 8. But because we are in the second quadrant, our x values are negative, so we'll get our x as negative square root 8. Diagram in the correct quadrant, our x, and then the answer for cos will be negative 2 root 2 over 3, or negative square root 8 over 3. Please do not leave your answer as a decimal, because the question is specific without using a calculator. The moment you leave your answer as a decimal, you have used a calculator. Sine 2b, so this is a double angle identity. We expand and we get 2 sine beta cos beta, and we substitute the value of sine and the value of cos beta, and we should get our answer as negative 4 root 2 over 9, or negative 2 root 8 over 9. And we get our answer there. 2.3, cos 450 degrees minus beta. Remember, we said if our angle is more than 360, we subtract 360, and that will give us cos 90 minus beta, and this will give us our reduction as sine beta, which is 1 over 3. So we reduce, and we should get our answer as 1 over 3. Identity, substitution, answer, we get our 3 marks there. So we should be able to get the marks for our cast diagrams. Please let us not only concentrate on this, also we must also check the condition that we are given. To just remind you, sometimes this question will be given as 3 sine beta minus 1 is equal to 0. So you must be able to move from here to there, and you should be able to see what is going, which quadrant and how. As you transpose 1, this will be positive over 3. Then you consider the condition for you to deduce which quadrant your diagram is going to lie. Now, for our identities, good people, we split into the left-hand side and right-hand side. We should be able to use the basic identities. Tan theta is sine theta over cos theta. Sine squared theta plus cos squared theta is equal to 1. And remember the other versions. I know that where I have sine squared theta, I can put 1 minus cos squared theta, and vice versa. Where I have 1 minus cos squared, I can put sine squared. Whichever makes life easier, it's what we should be using there. We should also see those that are having addition and subtraction of fractions, where we are using the LCD to simplify, or also use conjugates. A conjugate, when I have as a denominator 1 minus sine theta, its conjugate becomes 1 plus sine theta over 1 plus sine theta. So it's as good as I'm multiplying by 1, but this will give me 1 minus sine squared on my denominator, and then this becomes cos squared theta. So we must be able to see such things. And then We should also be able to factorize. If necessary, we use the highest common factor, the difference of two squares. We should know how to factorize trinomials by grouping, as well as a difference or sum of cubes. We should be able to do those. Our compound angle identities, like I said, if it's expanded, you should be able to move from left to right as well as from right to left. We should be able to use those. Now, cos, also we have those. Our double angle identities, we are having them there, and we should be able to use them to simplify expressions. Also, the general solution concept, we should be able to find our general solution of our trigonometric equations. Sin theta equals A, cos theta equals A, tan theta equals A. We know where we find our reference angle, we ignore the sign, and then depending on the quadrants, you are able to find the solutions in the given quadrants. And remember, we always add the k times. If it's a sine or cos function, the period is 360 degrees. If it is a tan function, our period is 180 degrees. We also look at our cast diagrams, and we know that for the sine and cos function, our minimum is -1 and our maximum is 1. So we should always check that. Tan, we know that our A can be any real number. Because of time, I will run through this activity, and we should be able also to prove these identities when we are practicing between today and Monday morning. Please refer to your checklist so that you are able to see the areas where you are comfortable and areas where you still need to put effort between now and Monday. We are supposed to prove that identity. Let's do it together. Cos squared, cos to the power 4 plus sine squared x times cos squared x. If you check there, I have a cos here, I have a cos again there. And it means somewhere I should factorize so that I'm able to simplify this. So I will factorize cos squared x. If I take it out, I'll remain with cos squared plus, if you check, I factor out cos squared, I'll remain with cos squared x plus sine squared x. But what do I see here? I know that cos squared plus sine squared is an identity. This whole thing becomes 1. But I know that cos squared is also an identity, which will give me 1 minus sine squared x. But I can factorize this numerator. This is a difference of 2 squares, and I should get 1 plus sine x, 1 minus sine x, and I see here these are like terms, and I'll remain with 1 minus sine x, and that should give my right hand side. I'm done with the proof. So highest common factor outside, knowing that this is 1, substituting the identity and then factorizing, and I will get my 4 marks there. Moving forward, the next one. This is the other alternative that we can use, where the identity of sine squared, we use 1 minus cos squared. Because there's a plus, you multiply before addition, and we get cos squared x minus cos exponent 4. These are like terms, they will give us 0, and we remain with cos squared x. We substitute its identity, we factorize, so we substituted that one, we got that one, we factorized, and we are able to get our answer there as 1 minus sine x. There are other alternatives. Please, for our identities, you don't cram. Just use what you are given to help you get what you need to get. And practice will help you see these things faster. You won't say because on the previous one I used this, therefore the next one I use the same. No, it all depends on what makes your life easier in that particular case. Moving forward, for which values of x in the interval 0 to 360 degrees is this undefined? If it's undefined, we know that we are looking at the denominator and we should get our x as 270 degrees there. Sine x is equal to -1. We get our reference angle and then we get our x as 270 degrees there. 2 marks. We must know the condition. Write down the minimum value of the function defined by y is equal to this. Now, how do we determine the minimum value? This is function interpretation. Our function is that one, 1 minus sine x. We know when we are dealing with the graph of this, we can write it as our y is equal to negative sine x plus 1. The graph of this function, we know that we are shifting it 1 unit up. We reflect the original graph of sine about the x-axis and we shift it 1 unit up. You should be able to get the minimum value of the function between 0 and 360 degrees. It will occur at 0 degrees because that should give us the answer there. We move forward. We are given the function cos, the identity cos A minus B is equal to cos A times cos B plus sine A sine B. We are supposed to use the above identity to deduce that sine A minus B is equal to sine A cos B minus cos A sine B. With that being said, we should be able to get that one. And then the next question, hence or otherwise, we determine the general solution of the equation that. Now, the first one, remember our sine, we write it as a cofunction, cos 90 minus whatever we have as our sine A minus B there. So we are using the fact that sine theta is equal to cos 90 minus theta. You are able to see that where there is theta, it's where we are having A minus B. So that's, we put our A minus B. Where there is theta, I substitute A minus B. I apply the algebra there and I should get cos 90 minus A minus, because that will give me plus, but according to my function there, I'm having a minus, so I should try and make sure so that I only substitute. Where there's A, I put 90 minus A. Where there is B, I should put negative B so that I have my negative sign in between there. That's what I did. Then I applied my reduction rules and I got the identity that is needed there. So we use a cofunction, we substitute, and we reduce to help us deduce there. Please do not just copy from the formula page. You will not get marks. Hence or otherwise, determine the general solution. So I see this is sine cos minus cos sine. Now you go to your formula page. This is similar to what I'm having here. Sine cos minus cos sine. So this is my A and this one is my B. I reverse it. I get sine 48 minus x is equal to cos 2x. I use my cofunction. It will be sine 90 minus 2x. These should be equal because they are the same ratios. So this will give me 48 minus x is equal to 90 minus 2x plus k times 360. I'll get my x as 42 degrees plus k times 360, k element of integers. This is my solution in quadrant 1. Quadrant 2, I will take my 90 minus 2x as my reference angle. So it becomes 180 minus my reference angle. So 48 minus x is equal to 180 minus my reference angle plus k times 360. And I should get negative 360, negative 3x is equal to 42 degrees plus k times 360, k element of integers. And then I'll get x as negative 14 degrees plus minus k times 120 degrees, k element of integers. Let us look at these concepts. Now, our trigonometric functions. Let's look at our amplitude, our period, our domain, our range, our standard graphs. We know the period for the sine and cos function is 360 degrees. Our amplitude is 1. And for the standard tan function, our period is 180 degrees. It has no amplitude. The asymptotes of the standard tangent graph are at negative 90 and 90 degrees. So we should be able to get our period there. How do we deduce period? We know that it is the original period divided by k when given the function. When you are given a function sketched, whatever is your period, you equate it to that and help you solve for k if k is not given. And we know those are examples that I have illustrated for you to use. Our amplitude, we know that we take our y values at the turning points, and we know that the difference will divide it by 2. We should be able to get our amplitude. Our shifts, we know that q affects our up and down movement. If it's positive, it's up. If it's negative, it's down. And we have our horizontal shifts as well, to the left, to the right. Standard sine graph, sine x plus 1, our graph shifts 1 unit up. It follows the same shape, minus 2, 2 units down. We should be able to interpret these. Our horizontal shift, the graph of sine x between negative 90 and 360. If it's sine x minus 30, you see that our graph shifts 30 degrees to the right. And if it's sine x plus 30 degrees, our graph shifts 30 degrees to the left. Check from that. We have this activity, you will do it when you get home. You can take a photo of it, but you are able to see which year it comes from. You can do it later on. How to determine the period, how to determine amplitude, our value of A, as well as the coordinates. The value of K, how do we get the value of K? Another way of dealing with the general solution, our transformations and knowing the graph interpretation is given there on our question 6.5. Now, we should be able to get the points of intersection by using our transformations there. Now, our trigonometry in 2D and 3D, we must know the proof of the sine, cosine, and area rule. The sine rule is used when we have two sides and a non-included angle, or when we have more than one angle and a side. Our cosine rule, we use it when given two sides and an included angle, or when we are given three sides. Our area rule, we use it when we have two sides and an included angle. And to solve 2D and 3D problems, it helps to redraw triangles, and we apply basic trigonometry. That's our sine rule, our cosine rule, as well as our area rule. In summary, please analyze the given information to identify what can be used. Always remember that diagrams are not drawn to scale. We cannot start measuring. As candidates, we must use the given diagram effectively. Add information to your diagram, label correctly, use the correct notation for angles, sides, and as when we answer questions, we add information to the diagram, as well as we draw in all additional lines so that we get a clear picture. You saw as I was doing questions, I was adding information to the diagram. And if the question says, show that P is this, you cannot use that P to answer question 2.2, yet that question is asked in 2.3. Let us always try to show what we need to show. And the properties of triangles and quadrilaterals must be revised thoroughly for analytical geometry. And use of color is encouraged, especially with Euclidean geometry. We must refrain from making assumptions. If they've not said the line is a diameter, we can't assume it is a diameter. Our next lesson will be in term 4, and it will be revision lessons. I wish you all the best for paper 2. Let's continue to study. Thank you so much for watching. Have a good afternoon.